Hi, today I'll be presenting on the topic of building a question answering application over structured data. So we will be using a graph database or a knowledge graph for this. So we are working with a course database which captures information about the various assignments which are part of the course. So this instructor file, I've added this. I'll explain why. We have different modules that are part of the course. We have information about students and uh, how the students have finished the assignments in terms of scores, attempts, and etc. And we have information about modules, like how much time students spent on modules, feedback and rating, and so on. Okay. Um, so basically, I created a knowledge graph. With five entities. I have an instructor, I have course, module, student, and assessment. These are all my entities. And these are the relationships. So teacher teaches a course, modules and assessments are part of the course, students are enrolled in the course, students have completed some modules and completed some assignments. Okay, so why did I choose a knowledge graph or a graph database instead of a SQL database? It's purely a design decision uh, because as we increase the number of courses and we increase the complexity of the relationship uh, we have between different entities, it will be much easier to work with a knowledge graph than a SQL database because graph database can traverse these relationships faster than SQL because in SQL, to traverse multiple relationships, you need multiple SQL joins, so which might reduce the performance. And also, graph DBs have flexible schema, meaning that they don't have to adhere to tight schema rules like SQL database. Okay, so I added an instructor node just so that when we scale up, we'll have like a lot of courses and a lot of instructors. So that's the reason for adding an instructor node. Okay, let's see how our pipeline works. So our pipeline so this is a sequence diagram which basically explains the flow of information or the function calls in our pipeline. So basically we have three components. We have the pipeline itself, which the user directly interacts with. We have a large language model. More specifically, we are using Google Gemini language model, and we are using Neo4j database for a graph database. So first, the user asks a question. When the user asks a question, we'll extract the named entities in that question. So what are named entities? So are there any student names, assessment names, module names, instructor names, course names, and so on in the question? So that's what we do first. We extract the entities. So this is the prompt that we use to extract those entities. Once we extract the entities, we need to find the matches for those entities. Suppose the user asks a question about Rohit. Rohit is not a might not be a valid value in the database because the database might have my full name like Rohit Mapakshi. So constructing a cipher query from the text in the answer in the user question is not a good idea. That's why we get the DB matches for entities and start using them. So if you see the cipher prompt, we basically in the prompt we basically pass the schema of our database, which is a textual version of this data model, and we pass an entity list. This entity list is not just the named entities. We combine it with the DB matches and send the database values in the prompt. We send the actual question and then we ask the LLM to create a cipher query. So once we create a cipher query, so we'll do some validation steps here, and then we'll query the database with the generated cipher query to get the answer. So once we get the answer, we again ask the LLM to construct a response. in natural language and return the response, which will be the final answer. So why is this necessary? Suppose the user asks about feedback and there is a lot of feedback. What the LLM does is it kind of summarizes the feedback instead of directly giving out the actual database values. So, and also it makes the response seem more natural. So we'll quickly see a demo now on how the system is working, and then we'll go through the code. Uh, yeah, let's move on to the next module. Okay, now let's see a quick demo on how our system works. I have the data model opened on the side so that we can verify if the produced queries make sense according to the entities and relationships. We will begin with some basic queries and then uh, keep on increasing the complexity of the queries. So basically, I have three types of queries. I have questions about student engagement, like how many students have finished a module or assignment of the course and so on. I have some queries about performance, like how are the students doing on the assignments, how was the final exam and so on. And then finally, we have questions about content and quality, like what did students think about the content in module X and so on. Okay, let's see. Let's begin with some basic queries. So here I have my demo file. Let's run this. Okay. How, okay, let's ask about teacher. Who is the teacher? Okay, so we have an instructor. That's me, sensei. Uh, how many students does Rohit teach? So ideally it should go through this line. Okay. Okay, yeah, there are 20 students. Let's ask more queries about say enrollment. How many students are enrolled in the course? So basically, these are all same queries. We'll do something to change. We have already validated that this is working. Let's ask. So I have added a special example to kind of yeah, I'll show it how many students have completed the course. So here the LLM has to capture the meaning of completed. So there are various ways we can help the LLM do this. We can give some examples to make the LLM understand, or we can write tools which we can inject into the LLM that kind of adds meaning to certain words. So here in this case, I have added an example. So I know this query works. Only 9 students have completed the course. The way it calculates this is it basically checks uh, if this counts the number of students who have completed all modules and assessments. So I already know this works. Let's um, try something different. Who are the top 3 students? Okay. Um, okay, let's see. So it's basically summing up the score. So this is not what we want. We want average. Who are the top 3 students based on average score? I mean, it's technically right because still, like the total marks also count when you are asking for top 3 students. Anyway, we can see that it's giving average score as well. Okay, let's go more performance related queries. Let's check performance. How is Emily doing? So Emily has completed four assessments, scoring an average of 87.75. Let's check this. Has completed five modules, spending an average of 46 points. So this is also kind of an example that I added um, to capture the meaning of doing. So basically, to query all these things and give a summary. Um, let's check if this is working. Like, how are students doing on the assessments? Okay, so what is this doing? Students who have completed assessment, return assessment name, count number of students, average score. Okay. So it's basically giving the average scores and number of students who finished it. This is a good summary. This is an acceptable answer. Let's ask about, say, minutes spent. How much time did students spend on each module? Okay, again, here it's doing some. Kind of makes sense because we asked how much time. Um, okay, I expected average, but yeah, this is also an acceptable answer. Let's see if it can give average. How much time did students spend on each module on average? Hmm, so this is not working. Let's try changing the query. On average, how much time did students spend on each module? Okay, average time spent per module. Okay, this is not what I want. Average time for each module. Okay. So, like I've noticed that sometimes the LLM doesn't work. So, one thing I've found is like to restart the demo. Sometimes it works. And also, by changing the LLM or the LLM temperature, it kind of behaves differently, that is acceptable because temperature is a variable that controls the creativity of the module. Um, okay, let's ask a different question. What? Okay, for which assessment did the students spend maximum time? Okay, so there's no time spent on assessment. So for which module? Okay. Earlier it said it has no time data on modules, but now it's working. So sometimes so if the query generated is not correct, we won't get any data from the database. In that case, the answer might be wrong. So again, this is just fine tuning at this point. We have to add more examples and more tools. and probably experiment with different LLMs and see how they are generating cipher queries. Um, okay. Um, who are the students who haven't finished any assessments? Okay, so we have four students who have not finished any assessments. Let's verify if this is correct. Let's ask about Angela and see if that is true. How is Angela GELA doing? Angela has completed four modules. Yes, she hasn't finished any assessments. So yeah, this query is right. So yeah, so in essence, the LLM is able to answer most of the questions with sometimes the whenever the LLM doesn't work, I had to restart the LLM to see if it works again. So basically, we have covered all the queries. Oh yeah, we haven't asked anything about feedback. Okay, let's pick a module. Global education trends. Okay, how do students feel about global education trends? Okay, so basically, what is this doing? Okay, so this is getting all the modules that the students have completed, returning module name and feedback. Okay, so again, this is a failure because global education trends is not passed as a attribute for module. So it means that our entity matching has failed. So try, let's try to copy this and see, try to debug this issue. How do students feel about that? See if this works. Okay, so how do students feel about module 5? Okay, this is failing again. So there are some queries that fail, um, but I verified that it works sometimes and it doesn't work sometimes here because here it's capturing this as a module name. It should give it as module ID. Um, let's see how do students feel about the fifth module. Let's see if this works. Okay, it's asking contains. Again, this depends on the temperature, so I probably have to try a different model on this. So uh, the system is not perfect, but I think by tweaking some hyperparameters, we can get most of the queries right. So all the engagement queries passed. Performance, I expected average, but it gave some for some of the questions. Difficulty, so I didn't finish this query because um, there's no information about difficulty as such. We can maybe ask a question like how, which assignment has the least scores? What is the average? score for each test line. Again. Okay, let's try changing our Gemini model, see if that makes a difference. Let's try Gemini 1.5 Pro instead of this, the earlier Flash model that we were using. Okay, we were asking about global education trends. How did students feel about global education trends? Yes, now it has correctly picked that global education trends as module 5. Again, so changing the module, changing the temperature, tweaking this is making like giving different answers. I mean, like improving the performance. So we have to test which model works for us the best, and then from there go about it. So yeah, please ignore these comments and to-dos. I was like basically testing all these things when so they were all errors while I was still working on the project. I forgot to remove them. So I've already validated these queries. Um, yeah, this is the end of the demo. Let's see how code works. Hi, now I'll walk you through the code. So this is our project folder. So our project folder has a .env file which has the app secrets. Basically, this has the database configuration, the password, the URI, and the username. And it has some keys for the LLMs. We have Gemini API key, which is the LLM which we are using. So if you want to add other LLMs, you can add the other keys as well. And then we have our config folder. So the config folder has application level configs, like what are the different LLMs and what are their particular, uh, what is the model or what is the configuration of that model and so on. And we have DB. Right now we are only using a graph database, so there's only configuration for this. And we have some file names here. So we have an example file, which are kind of the examples that we feed to the LLM to improve it. We have queries file, which has all the graph queries, and we have prompts file, which is used by the LLM. So I have externalized all the queries and everything so that our code is clean. So we don't have any hard-coded SQL queries or anything here. So the last two configurations are important. So use LLM is Gemini. So when we say use LLM is Gemini, our pipeline automatically picks this configuration and loads the model. Similarly, the database. Right now, we since we have only one database, uh, like I just set this up for future use. Suppose we want to migrate to a SQL-based database, then we can add a SQL configuration and call use database as SQL. Okay. And then we have the data folder, which actually has the courses. So basically, so you can add multiple other courses like this course folders, and the application will automatically load all the courses into the database. So I've set up a script for that to read this folder and convert whatever data there is into a graph database. And this is just a image folder for my README file. And then we have scripts. So, so this script setup Neo4j basically converts all the data into a graph database. So it has two options to clean up or like drop all the databases and basically empty out our entire database. And we have a function called setup database, which will load all these folders. So the way this code is set up is like you can just add multiple folders here, and the script will take care of loading all the data into the database. So let's see how this works. I'll just give a high level overview of this file since this is just a script file, and then we can go into the actual source code, which has multiple modules. Uh, yeah. So when we set up the database, so first we'll read the application config so that we'll know where the example files and query files are. Um, so we'll load these into a repository called Cipher Query repository. So this is in the data model folder. So I'll explain all these repositories and everything when we are talking about the specific modules. For now, let's just see how the script works. So basically, it takes every folder and process each of this folder. So for each of this folder, we'll first check if the course is already created. Suppose we have already processed this particular folder, we'll just skip creating that course and return. So if not, we'll create the course node, instructor node, student node, assessment node, module node, and then we'll read the relationships. The relationships in this database are here, which has completion ID and assessment, which links basically all these three things. So similarly, this is also a relationship file, which we use to set up our relationships here. So these are all separate files. So here, uh, basically I have all my queries stored here in graphqueries.json. So it has queries which checks if the course exists, instructor exists, student exists, all the CRUD queries of Cipher queries. We have them here. We also have some additional queries like entity DB match queries. So this is basically the same query. For fetching the DB matches, I've tested like multiple ways. I've searched like a normal DB query with contains. I've tried fuzzy match. I've tried node search, and I've tried full text search. So full text search works really well. The reason is basically after creating the data model, we create an index, full text index on the names. So what we do here is basically we get all the student names, module names, and basically all the named entities, and we create a text index on that. So our search works well. It will handle minor misspellings, difference in cases, and so on. Like all these are handled when we have like a full text search. So let's just see how this works. Suppose I already have my database populated. Let's see how the script works first. So if I say clean up database, will basically delete the name index and drops all the nodes and relationships. Now if I run this query, so you won't get anything. So it has cleaned everything. And then if I run it again, say setup database. So it processes the course folder, adds all the nodes and relationships, and creates a named index for our search operations. Suppose I run the script again. So it will skip this folder because we have already uh, processed this folder. So this script is just like a one-time setup. You just need to run it once to populate the database. After that, we can start experimenting with our main code. Okay, so let's see what the data model module is all about. So the data, so the module design is based on separation of concerns. So everything related to data, database, which includes the cipher queries and the examples. So the examples, if you see the examples will have a cipher query. So this also is very specific to graph database. So they are within the data model. And then yeah, and then we have in the data model module, we have this module called graph underscore DB. So this file basically has everything that is related to cipher queries. So we have a class called Neo4j. This class is used to perform CRUD operations on Neo4 database. So it has context management, meaning we can use it like how we open files so that the uh, so so the connections are automatically closed once the context of that function is over. And then we have a Cipher repository. So the Cipher repository, uh, the Cipher repository basically is a singleton class, meaning that we only there's only one instance of this class running throughout the life cycle of our program. This is because the repository loads these Cipher queries and examples from files. And we don't want the repository to load it every time we create an instance of this. That's why I made this singleton, because we have to reduce the number of file calls every time. So this is the code for the singleton. So basically, the first time we create any repository, we have to pass the file names for it to load. So if we don't pass it, then it will throw a value error and says that file names must be provided on the first initiation. After that, we can directly call Cipher query like without any of the input parameters for that object. So we have um, a um, get query function. So basically, we have to pass a certain query name like course exists, instructor exists, and so on. So it will basically fetch the corresponding query. So for example, if you say course exists, it will pull this query from the query repository. And then we also have a function to call all the examples that we have. So we have a lot of examples that help the LLM process some advanced queries. So, for example, if you see something like what did student think about the content in the module? So, think means we are talking about feedback. So, we want to map that relationship. So that's why I added this example. And these are not just some random examples. Like, for example, once I added this average example, all my functions started working in my queries, like sum, average, top three, and everything. So it's not about the quantity of examples, it's more about quality, like what exactly are you trying to do. So we have to add example one by one to see if the use cases are getting solved, and then stop when all the use cases are solved. We don't want to load too many examples. Okay. And then, so this is the entire data layer. And then we have our pipeline, which is the NLP pipeline or the LangChain pipeline that we are using. So in the LangChain pipeline, again, we have a prompts file. Um, so I put this file in this module because this is very specific to LLM calls. There are no DB queries here. We have lines which say cipher. That's why I named it as graph prompts. Suppose we are using SQL as backend and we want SQL prompts. We just have to create uh, something like SQL underscore prompts.json. And in our app.config, when we set up our SQL configuration, we have to give the corresponding prompts file. That is true for all the other files as well. And then we have our EduQuery pipeline. I'll come to this in a bit because this is the core functionality of our code. So we have an LLM module. So there are some classes here. So there's the LLM factory, which basically gets the LLM, uh, instantiates the LLM. Suppose right now we are using only Gemini LLM, so I've instantiated only that. So basically, this is a factory class. So suppose if you want to use OpenAI, similarly, we can instantiate our OpenAI LLM and then return it, and so on. Like we can keep adding more LLMs here. First, we have to add the configuration here and write the corresponding LLM instantiation code here. And we have this tools file. So I'm not using this file anymore. Like I wanted to use it. I'll just explain what I'm trying to do here. So LLM tools are basically certain signals that we can give LLM to say like, okay, if the query is like this, you can try doing this query or something. Basically, there are signals to help the LLM figure out how to build the best query. So I set up a strategy pattern here so the student performance tool can get a query strategy. What does this mean? Suppose I'm working on a graph database and I want to use a graph query. I can send the corresponding query strategy, inject the implementation here. So like once you write the tool and define what the tool is used for, you don't need to write any DB specific queries to actually execute it. You can just inject that implementation or that query strategy into this file. Um, so basically, this query strategy, yeah, it takes the query strategy and then executes that strategy. So I have not used this tool because my pipeline was already working well with the given examples. So I didn't feel the need to add more tools. Yeah. And then we have the main file, the EduQuery pipeline file. So this is an abstract class which summarizes our entire pipeline. I'll go through each and every one of these in a bit. So here in the EduQuery, we have a prompt repository, just like how we have a repository for storing our queries and examples. Here we have a repository which stores all the graph prompts that are used within the LLM chain. Okay, so this is also a singleton class because we want to prevent multiple file reads. So when you first instantiate it, that's when you have to pass the file name. So it should always be passed. Then it will create the object and store it in memory. All the subsequent calls can be directly called without the prompt file. It will work fine because we are using a singleton. And then it has like various methods. So let's keep this on this side. Okay. Okay, graph prompts. Okay. So we can ask our where did this? Okay, so we can basically ask our prompt repository to get the NER prompt. Then it will get the entity recognition prompt. When we ask for cipher prompt, it will give this prompt. When we ask the response prompt, it gives this prompt. So all the other methods are protected. That's why I added a preceding underscore here so that The user knows these are protected and only for internal use. Yeah, this is the prompt repository. Now let's see how our EduQuery pipeline is set up. This is an abstract class. The reason for creating an abstract class is because in our backend we are using a graph database. Suppose in future we want to change the backend system entirely, we can just write a new implementation of this class because and implement all the abstract methods of this class. That will be good enough to that will form like a template to create a new pipeline. So let's see what these specific functions are. So let me open the README file again for the sequence diagram. So basically, this prepare NER chain corresponds to the first call that prepares the LangChain pipeline to ask for named entities. And then we have an abstract method which maps to the database, which returns the database matches. And we have a cipher chain response, prepare cipher response chain, which corresponds to this part of the sequence diagram. And then uh, we have the response chain, which corresponds to this part of the sequence diagram. So this creates the cipher query, returns the cipher query. This gives the response. And yeah, and then a um, we have another method which actually combines all these things in sequence. So the reason for separating these functions is um, so for you, it's for unit testing. Basically, we can just check the NER part, how it's working. We can just check the matches, like if it's returning valid matches and so on. This will be very helpful to write test cases and test only a certain part of our, um, our pipeline. Um, okay, and then we have other classes which are basically supporter classes for the main pipeline. We'll see how this is implemented in our graph pipeline implementation. Okay, now we have covered data model and pipeline. So this is our this is just an experiment file which I've used like a scratchpad to experiment. So I have already added in git ignore, so it won't be on the GitHub code that I share. Um, so the graph pipeline is basically an implementation of the abstract class we just discussed. So since this is a graph pipeline, we can directly load only graph related things here and then implement the actual functionality behind the pipeline. Let's see, let's see the implementation in more detail now. So when this pipeline is initiated, what we do is we first load the config, which is our config, which is our application level config. And then from this, we check the use LLM attribute. We check the use LLM attribute. We check the use LLM attribute. And then we pass the configuration for that LLM into our LLM factory. So, and then we go into the LLM factory and get the Gemini LLM instance. And then we set it uh, in our class. And then we instantiate the prompts repository. Again, since this is a graph pipeline, we can directly say use Neo4j. We need not use this. So if we are going for SQL database, there we can directly say use SQL DB. And then we load the corresponding prompts file into the prompt repository. As I informed earlier, the prompt repository needs the prompts file only the first time. All the other times you can just call it without passing any files. Similarly, we'll load our Cypher query repository, which includes the graph examples and graph queries. Once they are loaded, so self.chain equals to none. This is for lazy loading. I'll explain this in a bit. Um, yeah. And then we load the graph. Okay. So there is one important file I've missed, which is the API keys.py file. So the API keys.py file basically handles all the secrets that we are storing in the .environment file. So this file reads the URI and all the API keys from the environment file, and we use it within our pipeline. So that way we have this is more like a API key manager, so we don't have to hard code or like write queries to read the environment file anywhere. So when the file instance is created, we directly read the environment file from here. We load it into the memory, and then uh, we get all our API keys stored here. So we'll use this throughout the pipeline. So from there, we'll load the graph too. So we'll use the API keys file to set up a connection to our database. So this is the initiation part of our code where we load the configurations, get the corresponding LLMs, initialize our repositories, and so on. So let's see the first step, which is the named entity recognition stage. First, we get the prompt from our prompt repository. We get the NER prompt, um, which is this prompt. We get the system and human versions of it. Like this is more like setting the context for the system, and this is the actual prompt that the human asks an LLM, and then we convert it. So again, this entities file is like a helper file, which basically says how we want our named entities to be returned. Basically, we want all our named entities like like a list of entities that are identified. Suppose if I ask a query, like how did Angela and John score in the assessment one? This entities will basically return the entities like Angela, John, and assignment one as a named entity list. So this is just like a template for the output which we will receive from the LLM. So basically the format of this line. So we create the NER prompt from the prompt we have loaded from the prompt repository, and we create an entity chain. So we pass the NER prompt to the LLM, and we ask the structured output, that is the list of entities. So this is the entity chain. Step number 2, matching entities with nodes and relations. So here from the query repository, we get a full text search query. So in the beginning, while we were setting up the database here in the script, in the final step, uh, we have created a name index so that we can easily match the identified named entities with the actual values in the database. I told that we had multiple versions. So now we are using full text search. So it will basically get that cipher query, and then it will query our graph with the match query and get all the nodes in the database. So this is step number two, matching the database. Step number three, prepare cipher response. So this is where we do a lot of things. First, we get the okay. First, we load some examples. So here uh, we have some. We've already set up some examples to help the model capture some meanings like how we saw in the demo, completed a course means completed both modules and assignments and so on. So we have some examples here. So we load those examples here. So basically, we get the example prompt, which is let me pull up the file. Oh yeah, graph prompts. Oh, not this. Yeah, we load this example. So basically, we have a question and we have the corresponding query that the system should return. So our example file is also set up in that way. So it will read the question and read the corresponding query it has to generate. So, and then we create a few short prompt. So here, what we are doing is we are basically injecting all these examples into our pipeline. The reason is we just have like five examples. Just these five examples will um, make 80 or 90% of our use cases. Like, I mean, we can solve 80 or 90% of use cases. So there is no need for um, any advanced message, I mean, example loading strategies here. Suppose, say, our use case increases and now we have like hundreds and thousands of examples. It is not a good idea to load all these examples into the LLM, which might confuse the LLM. So in that case, I didn't do this because this is an overkill for the given for the scope of this project. So ideally, we have to use something called a semantic similarity example selector. What this will do is, suppose I ask a question like, "How is Rohit performing?" What this will do is convert that question into a vector and do a vector search in a separate vector database. In that case, all these examples, instead of loading it, so right now we have all this in the query repository. When we migrate to this semantics similarity example selector, our query repository will actually be a separate vector database, which where we use a different encoder to encode all the questions. Then it will find all the similar questions that suppose, yeah, it will find only the examples which match the user question and loads only those examples into our pipeline. So that is a to-do task. So I have not finished it yet. Um, and then we create the prompt like all our previous steps. We again get this cipher prompt. So in the cipher response chain, we pass the entity chain. So from the previous step, we get the identified entities, and then we map them to the corresponding DB matches here, and we add the graph schema. So if you see the prompts here, the cipher prompt takes the schema, the entities list, and the DB matches and the question. So we are passing the entities list here. We are passing, yeah. So basically, entities list is a combination of both of these, and we pass the schema, and we also pass the question. Um, and then we use this cipher prompt, and also we inject all our few short examples here. So when we move to a more advanced vector based uh, example scheme where we pull only relevant examples. This will, we need to change this line as well. We need to change this line and we need to change this line so that examples are dynamically loaded now. And then this completes creation of cipher queries. And then we have the response chain. The response chain corresponds to the final part of our pipeline. Um, in the response chain, what happens is first, so by this time we would have already got the cipher query. So what we do is we validate the schema because sometimes the relationships, the arrows, if you have seen these cipher queries, there are arrows which indicates like where the relationship is originating and ending. So we'll just validate the schema before we hit the database and we pull the data, uh, and then we construct the cipher prompt. So there's a validation step and there's a cipher prompt where we get the system and human message, just like all the other prompts. So we get the question, cipher query, and response. So putting it all together. So basically, we will chain all we will add all the individually developed components together. So first step is prepare entity chain. Second step is prepare the cipher response. Then finally create the final response chain. So this will be our EduQuery chain. So this is also this is also an abstract method that we saw here. So it basically combines all the chains and finishes our pipeline. And then we have this is also an implementation of the abstract layer. So when in the demo, what happens is we lazy load the chain. Basically, when we instantiate the pipeline in our demo here, so we instantiate our pipeline, we use a question called ask function. So if the chain is not prepared already, then we'll prepare the chain. We'll go through this, like prepare a near chain. We'll follow all these steps. And finally, we'll set it to this chain, which we have left to none. This is just lazy loading technique so that we don't do extra operations when the user has not started asking questions. And then these are other protected member functions of the class, which helps us set up um, all the connections and everything. So clean cipher output is just like a helper function, which I've set up here because sometimes there might be markers, markers like AI message and all that stuff. The LLM output, I'm just this is more like a pre-processing or like cleaning our query kind of step. So this wraps up the entire chain. Suppose I want to use say I want to use only this step for a different purpose. Like I'm not working on EduQuery anymore. I want only named entities. I can just call this function step one and use this module separately. If I want only DB matches, I can use this separately. If I want uh, to get all from named entities to cipher query, this part of the pipeline, I can use this cipher response part and so on. So finally, if you use this, you'll use the entire pipeline. So it's divided in that way so that we can just use whatever part of the stack we need. So for example, if you only want NER, we can use something like graph EduQuery dot prepare NER chain dot invoke, and then we can pass the corresponding parameters. So that works. So all of this is like I've experimented with this here. Um, so yeah, I have not included this file in my git ignore because like this was more like a scratch pad. Say, suppose I want to change the backend now, like I want to use SQL query, what do I do? I basically create a new file like this, like SQL pipeline.py. I should then I will then inherit this class and start filling up all the other methods. By then, by the time we finish everything, the pipeline is entirely set up. So this code follows separation of concerns. So we have data layer separated from our pipeline, um, and so on. So like we can use every module independently, without any without any dependencies.